As we think about this problem, of course, there's lots to read here. G represents the height of the tree, and X represents the base, and here we have an equation that relates the two. Then we go down and look. What are we being asked to do? When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. So that's a rate. That's screaming related rate. According to this model, what is the rate of change of the height of the tree with respect to time? So that's dH dt, or the derivative of g of x dt, because we were told g just represents height. And they're telling us when the tree is 50 meters tall. So that's key. That's the instant we want. Note, this is not an instant of time. So we might have to find time. So now as we think of this, any related rate problem we want with respect to time. They told us that, so we're going to have to differentiate with respect to time. So the derivative of g with respect to time will be the derivative of the other side, and as we see here, we really have a quotient. I think of this as p over q. So the derivative of any quotient will be p prime q, the derivative of the numerator, times the denominator, minus the derivative of the denominator times the numerator, all over the derivative squared. But another key thing is that each one of these variables is an x, and I'm differentiating with respect to time, so I'm going to have an implicit term everywhere I have my derivative. So this is going to be times a dx dt, and this is going to get times a dx dt. So let's go ahead and take our derivative. The derivative of g will equal 100 times dx dt. Times my denominator 1 plus x minus the derivative of 1 plus x will just be 1 times that dx dt times the numerator 100x all over the denominator squared. So if I'm going to find this derivative, I'm going to need an x and I'm going to need a dx dt. Well, they told us the diameter of the base is increasing at a rate of 0.03 meters per year. That looks a lot like that dx dt I'm looking for in meters per year. But the x is not obvious. They told me height is 50. So if I go back and look at this base equation, g of x equals 100x over 1 plus x, and use that 50 where it would go, now I have an equation that will give me x. So I could cross multiply 50 plus 50x equals 100x, subtract 50, 50 equals 50x, x equals 1. So that means I know everything I need. I've got my 1 for x, and I've got my 0.03 for dx dt. So as we calculate this all out, we're going to have 3/4, and we're going to have units here. Meters per year is our height, and we were asked to find. So amazingly, they've told us the units in the problem. 3/4 of a meter per year, and this is increasing because we have a positive quantity.